All right, welcome back. So before we do the next problem, I want to just talk about just one little bit of theory. Okay, it's not really hard, but we're going to take the Laplace transform of t to the n f of t, and this equals -1 to the n times the nth derivative of the Laplace transform, which we're going to call f, with respect to n. Okay, so let's just go ahead and see how that works. So we're going to let's take L of f equals f. That's going to equal from 0 to infinity e to the negative st f of t dt. Okay, so now let's take the derivative of this. We're actually going to go with the other way around. We're going to take the derivative of this with respect to s. Okay, we could just bring that derivative inside the integral. So we take that, and that's going to be what? The integral from 0 to infinity, negative t e to the negative st f of t dt. So this is what happens for n equals 1. It's true. Okay, this is a common trick. So now if I do this again, if I take the second derivative, that's going to multiply, that's going to be what? Doing the same sort of steps. That's now going to be negative t squared e to the negative st f of t dt. Okay, so we're seeing we're getting that -1 to the n coming out from here. Okay, so this is how that comes out. Okay, so we're going to need that in this problem. Okay, so this problem is number 36. Now 36, it actually only uses 1, so it's t y double prime minus t y prime plus y equals 2, with y of 0 equals 2, y prime of 0 equals -1. Okay, let me just get a drink of water here. Okay, so L of y is, of course, just, I'm going to write that as y, like so. Now ty prime. Ty prime, the Laplace transform of that is going to be what? Negative the derivative with respect to s of the Laplace transform of y prime. Okay, so we're not, it's a little confusing there, but it's, you got to take the Laplace transform of y prime first, and then you take the derivative with respect to s. Okay, so that's going to be, or that is, negative, let's write it d ds of, now the Laplace transform of y prime is, remember, s y minus y of 0 is y of 0 is 2. Let me write it this way first. Okay, doesn't matter, y of 0 doesn't have an s. So this is going to just be, so negative, the derivative here with respect to s is going to be y prime, oh no, ugh. Well, we'll deal with it, minus Wait a second. My bad. Minus sy prime, actually, minus y. There we go. Okay, so far so good. Let's do the same game with ty double prime. L of ty double prime is going to be negative derivative with respect to s of L of y double prime. Okay, so that's going to be negative derivative with respect to s, okay, of s squared y minus s, what is that, y of 0 minus y prime of 0, is that right? Just double check. Yes. Okay. I didn't have it written down because yesterday I was thinking straight. Today I guess I'm not. Okay, so now we're going to take the derivative of this with respect to s. That's going to be negative 2sy plus s squared y prime minus y of 0. Oh, y of 0 is 2, so let me change that to 2. Okay. All right, so let's go ahead. Let me highlight that. Okay, finally we have the right-hand side is 2, so we're going to have to take the Laplace transform of that. That's just 2 over s. We're good with that. You guys are pros at that one. Okay, so let's take our differential equation. Let me actually just go to a new page. Okay, I'll delete that now, otherwise I'll forget. Okay, so we've got our differential equation is going to be, or is, negative 2, negative 2s, oh, let me write it. I'll get it eventually, negative s squared y prime minus 2s y plus 2, that's my y double prime, minus negative s y prime minus y plus y equals 2 over s. Okay. All right, that does agree with what I had yesterday, so I'm going to trust that both times I did it right. Okay, so now let's go ahead and write this as, just try to isolate the y and the y prime. Okay, so we're going to take y primes have s minus s squared y prime. Okay, the y's have what? Negative 2s plus 1, so plus 1. No. This 2s is there. So, I'm sorry. There we go. These two add together. There we go. 2 minus 2s y, okay, plus, let's see, 2 equals 2 over s. Okay, so let me write this a little bit differently. Let me write this as s times 1 minus s y prime plus 2 times 1 minus s y equals 2 over s minus 2. Okay, but let me just write that let me write that again. Left-hand side, I'm not changing anything on yet. But the right-hand side, I'm going to write as 2 minus 2s over s, which I'm going to factor out at 2. Okay, so I'm going to go ahead, cancel out that 1 minus s. Okay, now, of course, I'm saying, well, s cannot equal 1, but what does s equal 1 even mean for Laplace transforms? I'm not sure I know what that means. Yeah, I don't have no idea what that means. Okay, so we're going to have s y prime plus 2y equals 2 over s. What do I do with this? I have a differential equation for y, for the Laplace transform of y. So I'm going to have y prime plus 2 over s, y equals 2 over s squared. Make this a little bit higher up. This is an integrating factor problem. You remember that? Yeah, our integrating factor that's way back to, I mean, we've even done it in the class before I've taught this lesson. Okay, but that means nothing if you're seeing this outside of the fall 2020 semester. But we did this like 2 months ago. Okay, so integrating factor is going to be e to the integral of 2 over s ds, e to the 2 natural log of s, that's s squared. Okay, so that's what we're going to multiply both sides by. So we're going to get s squared y prime equals 2. Okay. S squared y prime equals 2. So, give me just a second. All right, sorry about that. S squared y equals 2s plus a constant y equals 2 over s plus c over s squared. Okay, so that's the Laplace transform. How about the actual one? Well, that means y of t equals 2 plus ct. Oh, the c. Where am I getting the c from? Well, what haven't we used yet? We have not used the fact that y prime of 0 is negative 1. I don't know about you guys, but when I got this answer, I felt so enormously cheated because I was like, all that for this? And then I look back and I go, like, yeah, it solves it, sure, right? Because y prime is -1. So this is going to be that's 0 minus t. Wait a second. No, yeah, y prime is -1. So yes, 0 minus t plus 2 minus t equals 2. I felt so enormously cheated after this, but I imagine this technique will still help us for solving other problems. Okay? That's it for today. That's it for solving Laplace transforms and inverse Laplace transforms. I'll see you all in the next set of videos.